Today is November 3rd, 2011. We're going to be reviewing factoring quadratic expressions. We're going to do a question from your blue notebook, page 256. We're looking at question I to start. When I look at this, I have to recognize, first of all, it's not a trinomial. There's only two terms in this expression. And when it's two terms, I want you guys to think of, first, a greatest common factor. That's always the first thing we go for. So greatest common factor. Can I take something out of 49 and 81? No, there is no greatest common factor. Next, I'm going to look for special factors. Special factors, that means we're looking for a difference of squares. Because we know the other type of special factors we can just do by normal factoring. Does this look like it could be a difference of squares? Could I find the square root of the first and last term? Yes. This does look like a difference of squares. So we're going to use that method to solve this. What that means is I need to find the square root of the first term and the square root of the last term. So first of all, I'm going to square root 49 and I'm going to square root r squared. What will I get for both of those? 7 and r. So the square root of 49r squared is 7r. So we're going to combine those. We get 7r. And then I need to find the square root of 81 and the square root of s squared. That's an 8. Square root of 81 is the square root of s. So for the next part, I have 9s. So my first term I put in each bracket is 7r. And the second term I put in each bracket is 9s. And because it's a difference of squares, we know with our rules, I'll quickly write it again underneath, a squared minus b squared can be factored by a minus b times a plus b. So in other words, I need a positive and a negative sign in each bracket. So I put a negative in the first and a positive in the second, and we have our answer. I'm just going to move this to the side, or at least down a little. We'll rewrite our answer. It's the exact same as above. We have 7r minus 9s times 7r plus 9s. Doesn't matter which one I put it in. Just make sure there's one of each. Okay, our next question is 6x squared minus 17x plus 7. So, first off, GCF. Can I find a greatest common factor of all these terms? No. Special factors? In other words, can I find a difference of squares? No, there's three terms here, so we definitely don't have just two terms. There's three of them, so I can't find special factors either. So we're going to go into our factoring. Okay, if we remember from our factoring, I'm just going to move it over a little. We're going to look for the factors of our first term, 6. Okay, factors of 6 are 1 and 6, 2 and 3. Now I want you guys to remember though, technically, is 1 times 6 6x squared? No, it's just 6. So I know I hadn't been writing it in, but technically it's 1x times 6x, or 2x times 3x. Okay? So I'm going to add those in so you guys notice that. Then I look for the terms of my last number, which is 7 and 1. We know their products need to add together to be what? 17. Sorry, negative 17. Again, though, I want you guys to notice, if I multiply, which we're about to do, 2x times 1, or 2x times 1, we're going to end up with 2x. So technically, our middle term isn't just 17, but it's 17x. And again, I've been excluding it because I wanted you guys to just get used to the numbers, but we can start adding them in now. So we need it to actually be negative 17x. So we have our two columns. We're going to go trial and error. We're going to multiply first. 1 times 1x, 6x times 7 is going to give us 1x and 42x. Any combination of that going to make 17x? No. Okay, let's go across. 1x times 7, 6x times 1, we're going to get 6x and 7x. Any combination of that going to make negative 17x? No. So we know this first column is going to be no good. Let's try a second one. 2x times 1, 3x times 7, 2x and 21x. Any combination of that going to make 17? Let's go the other way. 3 times 1 and 2x times 7 going to give us 3x and 14x. Any combination of that going to give us 17? Yes. So 2x times 7 is going to give us 14x. 3x times 1 is going to give us 3x. But how would I make it 17x when I add them together? They both have to be negative. So that means this second term, negative 1 and negative 7, they both have to be negative. And to make sure it works, does negative 1 times negative 7 equal positive 7? Yeah, so we know that's possible. That will work. So when we go to put it in our factored form, we know our first terms are going to be 2x and 3x. Now, this is what's important. I multiplied 2x times negative 7, so the 2x and the 7 have to be in different brackets. So I put negative 7 in the other bracket. Same idea with 3x times negative 1. 3x and negative 1 are going to have to be in opposite brackets. And we now have our factored form. Okay, we have a very similar question. This time I'm going to use decomposition. To solve this, okay? Again, if you prefer to use the other method we just did, follow along using that method, you'll still end up at the same answer. So in decomposition, we still look for a greatest common factor first. We look at the three terms. Is there a greatest common factor between these three? 1. 1 won't change anything, okay? So we're going to leave it. We're also going to look for special factors, or in other words, difference of squares. Is this a difference of squares? No, we got 3 terms, so it's not either of those. So let's go right into factoring. Okay. Now, through decomposition, we have to label our A, our B, and our C term. And remember, we need 2 numbers that are going to add up to B. What is our coefficient in front of our B term? 1. So we're going to have to add up to 1. And also the 2 terms have to multiply to A times C. This is our A, our B, and our C. What would A times C be? Or equal. I shouldn't say B, confusing. 56 positive? Negative. We have negative 14 multiplied by 4. That's going to give us negative 56. So we need to find 2 terms that add to positive 1 and multiply to negative 56. So I'm going to start writing out factors of 56. So we have 56 times 1. 2 times 28. Does 3 go in? Anyone know? No. Does 4 go in? 4 times 14. 5 go in? 6? No. 7. 7 times? Okay. So now that we've got 2 factors that are so close together, we know we've completed them all for whole numbers. We got to go through these pairings. Now, remember, we're multiplying to negative 56, so I know one of these terms is going to have to be negative. I'm not sure which it is. Could jump around and try. So, let's look at the first one, 56. Any combination where one of those is negative going to get to 1? No, so that won't work. Any combination where 28 and 2? No, that won't work. How about 14 and 4? 7 and 8. What would have to be negative? The 7. If the 7 is negative, negative 7 times 8 will give us negative 56. And negative 7 plus 8 will give us 1. So those are the two terms we're going to break our B term into. Remember, we're going to split up our B term for decomposition. So what that means now, I'm going to rewrite the question. It was 4z squared plus z minus 14 equals 4z squared. I'm going to break our z term into these two terms. So negative 7z and positive 8z minus 14. The reason we can do that is because negative 7 plus 8 is going to give us just z. It's going to give us 1z. Now that I've done that, I need to factor by grouping, so I'm going to put little brackets around the first two. Don't forget to keep our addition or subtraction sign, whatever it is, separate, okay? If the brackets were beside each other, like this, that would mean we're working with FOIL method, which we're not doing right now, okay? So that bracket has to split. There needs to be some operation between the two. We then look for a common factor in each bracket. So a common factor in the first bracket would be what? Z. That's right. We're going to divide both of these by Z. Z comes to the outside of the bracket. What would I have inside? 4z minus 7. I also look for a common factor in our second set of brackets. Is there one? Right, 2. So that means 2 comes outside of the brackets, and what would we have inside? Minus 7. Good. Now that we've done that, if you take a look, both of our brackets are the same. So because they're both the same, we're going to factor each bracket out. I have 4z minus 7 is one bracket. Our other bracket is whatever's left over when we factor, which is our z plus 2. So we have z plus 2 in our other bracket. So our final answer is a set of brackets multiplied by each other. That's our factored form. So if you're confused on this step here, where we had two sets of 4z minus 7, think of it like this. Let's say I replace that 4z minus 7. I'm going to replace that with x, okay? I'm going to replace both of them just for argument's sake. And that means we're going to have z times x plus 2 times x. What can I take as a common factor between z times x plus 2 times x? I could take x out, and I'll be left with what? Z plus 2. Well, if I go back and replace my x now with what it was originally equal to, I get 4z minus 7 times z plus 2. Okay? So in other words, I'm using that bracket as the common factor, and I'm factoring out the entire bracket because it's common in both terms. Okay, blue notebook, page 257, 5K. This time we are factoring, but in this question, we have two different variables, an x and a y. We still take the first steps the exact same. We look for a greatest common factor. Is there a greatest common factor I can take out of these terms? Yes. So we know we can take out a 3 as a common factor. That means the 3 goes outside of a set of brackets, and inside the brackets, we equate the 3 terms. 9x squared divided by 3 will give us 3x squared. 3x times y divided by 3 will give us x times y. And negative 6y squared divided by 3 will give us negative 2y squared. So I now taken out a greatest common factor. Look inside again. Are there any other factors I could have taken out, a greatest common factor? Okay, no more greatest common factors. Special factors. Is it a difference of squares? Does it have 2 terms or is it 3? It's 3. So if it's 3 terms, we're going to use our Tanani method to solve this. So I'm going to find the factors of my first term, which is 3x squared. That gives us 1 and 3. And what's important is it's 1x and 3x. Then the factors of our last term. The number 2 are 1 and 2. But again, because it's y squared, it's 1y times 2y. We know that the products, when we multiply them together, need to add up to positive x, y, or in other words, positive 1. So we're going to multiply our columns across. This one looks like it's going to be pretty straightforward. Let's try 1x times 1y, which will give us 1xy. 3x times 2y will give us 6xy. Does that combination work? No. Let's go across. 1x times 2y will give us 2xy. 3x times 1y will give us 3xy. Will that work? If what? Yes. So we're going to multiply 3x times 1y, 3xy, and 1x times 2y, 2xy. In order to add up to positive 1, though, the 2 is going to have to be negative, which means the term we multiplied by, which is our 2y, will need to be negative. Now let's double check. Does 1y times negative 2y equal negative 2y squared? Yes, that works. So in our factored form, we bring down the common factor, which was 3. Our first terms we know are going to be 1x, or just x, and 3x. And when we go to put in the second terms, I multiplied 3x times 1y. So 3x and positive 1y have to go in opposite brackets, or positive y. And because I multiplied x times negative 2y, x and negative 2y have to go in opposite brackets. So negative 2y goes in this bracket. So our final answer is 3 times bracket x plus y times bracket 3x minus 2y.